Hello, everybody, and welcome to Wednesday, February 10th, 2021. Mr. Perry here with your science rundown of what we're doing in class today. First things first, make sure that you've got everything finished from yesterday. Submit up the visual vocabulary assignment. Make sure you got all your pictures in there. Make sure that you do today's bell ringer. And then, without further ado, we're going to get into our next thing, which is talking about the scientist who discovered genetics and his experiment that went along with it. So we'll dive into that here today. This is objective number 3. You can find the notes in the folder, so you can always check these things out in the folder, or follow along with me as I kind of explain some things here. Let me move down here. There we go. There he is, Mr. Gregor Mendel. He is considered the father of genetics because he basically discovered the basis of how genetics would work. He was from Austria, not Australia. Austria, it's a country in Europe, right next to Germany, I do believe. And he was a monk, which means he worked at a church. So something that you wouldn't maybe think of as too sciencey of a thing there. And what he did was that he was the gardener at the monastery, which is like the church they worked at, and he was in charge of the garden. So he was in charge of growing all the plants and whatnot, and he specifically did his experiments using pea plants as the number one thing for his experiment. Why peas? It was something that he grew, but they're also self-pollinating, which means they do not need another type of pea plant to pollinate them. They can pollinate themselves. Which means you can just constantly keep on growing them one right after the other. Take the seeds from one, plant them in the ground, have a new crop, plant them again, have a new crop, plant them again. So they're self-pollinating in that way. The traits of pea plants are very easy to see, which is why they also worked out very nicely for him. And then that they grow relatively quickly. It's quick to grow a pea plant as opposed to some of the other crops that he was growing. So that's what he specifically focused on with those traits. So his major accomplishment was dealing with his experiments that he did involving pea plants. Now I'm going to move myself back up top so you can see that picture because we're going to be referencing that. And this is Mendel's, what he calls the F1 experiment, which the F stands for familial or family experiment. Here, I'll make myself smaller there. And what he did was that he took a purebred tall plant, so something that is tall. Let me get my pointer out here. So here's our tall parent. And he bred that specifically with a purebred short plant, just to see what was going to happen. Who knows what they're going to end up doing. But he bred a purebred tall with a purebred short. What he was originally expecting was that he was expecting a medium-sized plant, something in the middle. Because you take something tall, you take something short, you're going to get something in the middle, typically speaking. But his results was something that was puzzling, because all of the offspring, all of the children were tall. And he thought to himself, that doesn't seem right. We specifically put a short parent in there. Why aren't some of them short? He was confused by this. He didn't understand what was going on. It is almost as if the short trait disappeared completely. Everything was tall. And he spent each one of them totaling up. He has there's pictures of his notebook journal of every tally mark that he had there. All the tally marks filled were tall. 0 short tally marks going on there. Puzzled him. Where did the short trait go? So what he did was that he did another experiment. So he was like, all right, let's take 2 of these pea plants that just grew up to be tall. What happens if we bred those together to make the next generation? So he called this his F2 experiment, the second family experiment. He took all of the tall offspring from the last experiment and bred those together. So all the ones that were tall, he bred together that just got produced from the purebred tall and the purebred short parent. He bred all of the tall offspring together. In the next generation, he was puzzled once again because he ended up getting 75% of them to be tall, but all of a sudden, boop, here's a short one. Boop, here's another short one. Boop, here's another short one. 25% of them were short. So how that would look is that if you're dealing with 4 pea plants, let's say it made 4 babies, 3 of them were tall, 1 of them was a short. Somehow the short trait reappeared. Here's confusion how this worked. Well, what happened? None of them were short before. Now all of a sudden the short is coming back. What is going on with these pea plants? That's what led him to dig deeper into it. And he started working with other traits. He worked with, whether they were round or wrinkled, or whether they were green or yellow. Because if you didn't know, the opposite color for the green pea plants, the green is usually dominant. The yellow one is a recessive color. So you could have yellow peas going on out there. You don't really see them too often, though. So what he ended up getting out of this was our principle of dominance. We talked about the principle of independence the other day. He picked up the principle of dominance because he demonstrated that all of a sudden there were dominant and recessive traits. That is why all of a sudden the short went away. It's not because it literally disappeared. It was just because they were paired up with a dominant trait always. And the dominant traits always are the ones that show if they are a part of your genes. So you're not exactly a blending of the combination of both your parents, but you either show one version of a trait or another. It's not necessarily a blend. You're not going to get tall and short and be medium. You're going to take after one half of your trait or another half of your trait. And that's what the principle of dominance kind of summarizes here with this whole thing, is that with our dominant and recessive traits, if you are dominant, you are going to have that characteristic, that trait. If you're recessive, you have to have one of each from both parents in order for you to be recessive with it. There's a video that kind of goes into this more that we're not going to watch because of copyright and reasons, but the video is going to be in there. It's a nice little 3-minute TED Ed explaining how these pea plants go into detail of how they help out with it. And then that's it, because we're going to get into objective number 4 tomorrow. So that's it as far as our notes go today. Your assignment is going to dig in a little bit deeper into Mendel himself. So I'm going to pull up Schoology here and let's take a look at our assignment. Let's go down to February. Let's go in this week's. This will be on Wednesday. It's called the assignment Mendel. It's a Schoology assignment. So we'll need to preview this. On these ones, I've gone away and got rid of the 3 attempts. You only got 2 attempts from this point going forward. So make sure you use those wisely there. Really make sure to check over your answers before taking it again. So make sure you utilize those to your full abilities there. And what we've got is that I've taken an article about Mendel's life and I have snapshot a couple of them, and I have given you some questions based off of that. There is 4 different sections. There's stuff dealing about Mendel's life, stuff dealing about the pea plants, stuff dealing about his experiments, and then stuff summarizing our 3 principles that genetics go off of that Mendel published in his first book back in 1865 called Experiments in Plant Hybridization, basically meaning what I figured out about the plants. And he came up with these 3 principles, which still work to this day. So there's a couple of questions dealing with his 3 principles. We've talked about 2 of them already. We haven't talked about the last one yet. That one's coming up here. Tomorrow we'll probably get into a little bit of that, so it's a little preview of what we're looking at tomorrow too. And then when you're done, you submit it up and be on your merry way. That is the assignment for today, along with our notes. So if you have any questions, do not hesitate to email away. Hopefully you're back with us sooner rather than later. And with that being said, I'll let you go here. Hope you're staying safe. Hope you're doing well. And I will see you later. Bye.